Hello everyone. So today we are going to solve our next problem of the Blind 75 series, that is threesome. Okay. So let's read through the problem. So given an integer array nums, return all the triplets, nums of I, nums of j, nums of k, such that their indexes are not equal. Okay. And nums of I plus nums of j plus nums of k is equals to 0. Okay. And it is also said that notice that the solution set must not contain duplicate triplets. Okay. So now I hope you understand the question. So it's simple. Like we need to find a combination of three different numbers whose summation is coming to 0. Okay. And their indexes should not be equal, right? Like I cannot include minus one twice and adding 2. That would also result in a 0. It should be a different index every time. Okay. So, and it also means that we cannot have a duplicate triplet. Like if minus 1 would have been at a different index than this, okay, then we cannot include a duplicate triplet. The triplet should also be unique. Okay. So let's move on to the approach. So what is the brute force approach you can think of? Like what is the naive approach you can think? So what I can think of is like I need to find sum of three different numbers. Okay, sum of three different numbers. So what I can do is I can fix one number using a for loop. I can take another for loop to go into the second number, and then I can take another for loop, right? Which will iterate over whole of this array, right? So so one for loop would start iterating this whole array. Another for loop would start iterating through I plus one. This is a fixed number, so it will start iterating from 0. Okay. And then another for loop will iterate over the whole array. And then we'll add all those three indices and we'll compare if it is 0 or not. And then we'll add it to a result, right? And then uh, in the outer loop, we have fixed this. Now in the next outer loop, we'll fix this. So this way it will go on. But it would result in cube complexity, right? Because we are having three different for loops, right? So it will result in n cube complexity. So I want to avoid that, and you should also avoid that because if you can see here that the length of the numbers is reaching up to 3000. Okay, so for larger inputs, there will be wrong output. Okay, so we can optimize the solution. We can obviously optimize the solution. So what I can do is I can use a two-pointer approach. Now you might be thinking that how could I use two-pointer approach? That because we need to find three numbers. So what I can do is I can fix one number. Okay, I can fix one number, and then I can apply two-pointer on whole of this array. So I can fix minus one. Okay, and then I can create two pointers, and then those pointers would move, and I can check the summation. Then when this whole iteration is done, then I can fix another number. Then I can move two pointer elsewhere. Okay. So this way, the solution can be computed in L square time complexity, which is still better than N cube time complexity. Okay. And so, and for that, what I can also do is I can sort the array first. Okay. So if I sort the array, what will happen is that I don't need to basically like if the summation I'll check like if summation is less than 0, then I need to move J index. I can explain. So what I can do is that suppose here I have I index, which I have fixed. This is the J index. This is the K index. Okay. Now, what I'll do is that if the sum is less than 0, okay, if the sum is less than 0, then I can increase the value of J. So now J would point at 1. So this way I could increase my sum. If I have to decrease my sum, if the sum is greater than 0, and if the array is already sorted, then I can reduce the k. K would be at the last index. So firstly, I need to sort my array, and this way I can increase j and k. Okay, so let's move on to the code. Then you will understand the things better. Okay, so I can take my result variable. Okay, so I've declared my result because I need to have this result. Now let's consider the base case. Okay, now we have to find the triplet. But what if the array size is less than 3? Then we can not have a triplet, right? So if nums dot length is less than 3, then in that case, we cannot have a triplet. So we'll return the result. Currently, the result is empty, so it would return null, right? Now, I have to fix one number, okay. But before that, I have to sort the array. So I can use arrays dot sort to sort the array first. Okay, so this would sort the array. So what will our array would become? So if we consider the first example, so the array would become -4, -1, -1, 0, 1, and 2, right? Now I have to fix I first. I would fix I to -4. So for that, I can use a for loop. Okay, for int I equals to 0, I less than nums dot length I plus plus. Okay, now I have to take two pointers which will iterate over this whole array so that I could get my sum. I could compare my sum. So I have taken, so I can draw this to, so, so this would be my I, -1 would be my j, and the last index would be my k. Okay, got it. Now, so what I can do is, so j should be I plus 1. Okay, so int j equals to I plus 1 because we will start it from the next index of I. Okay, and k would be at the last index of the array. So it should be nums dot length -1. Got it? I hope it is clear until now. So now, as I said, like now the array is sorted. Okay, so suppose if I do -4, so this is my I, this is my j, this is my k. Okay, now suppose if I do I plus j plus k, nums of I plus j plus k. Suppose if I make a condition, nums of I plus nums of j plus nums of k. Okay, so -4 plus -1, that is -5 plus 2, -3. So sum is less than 0. Okay, so what if the sum is less than 0? So if sum is less than 0, it means I have to increase the sum. How the sum can be increased? So if I move to the right, since the array is sorted, the sum would increase, right? So k is already at the rightmost part and j is here. Okay, so I can necessarily increment j so that the sum could be increased because it is less than 0 as of now. So I could increment j, right? So if I would increment j, so again, j comes here. Again, it is -1, sum is -3. Okay, j goes here. Sum becomes -2. So, right, sum is increasing. Then j comes here, sum is -1. So sum is increasing. So we can put it in that condition. Else, if nums of I plus nums of j plus nums of k, if it is greater than 0. What if it is greater than 0? Suppose if it would have been a +4. Okay. So now 4 plus -1, it's -3, it's +3, then +2, it's 5. So I have to decrease the sum, right? I have to decrease the sum. So if I have to decrease the sum, I have to shift k backwards because the array is sorted. So k is at the largest element. So I have to reduce the k so that the sum could be reduced, right? Makes sense. So I would reduce the k. So k would be minus minus, right? I would revert it to the original example only, -4. Okay. Now else. So we have checked the lesser than condition. We have checked the greater than condition. Now if it is equal to 0, right? So we have got our answer. So we can add that to our result. So we can add result dot add. Now, since we have this nums of I, nums of j, nums of k as an array, so I can use a method to convert it to a list. So arrays dot as list. Okay. So I would pass in nums of I, nums of j, and nums of k. So far, so good. Okay. So now what is happening is that we got our answer in the result. Okay. But in the question, it is also mentioned that the solution should not contain any duplicate triplets, right? It should be unique. So firstly, I'll add a while condition in here. Okay, while condition, so that like I missed that while condition. So that will basically help us like when J and K would meet, at that time we have to increment our I, right? So I'll wrap this code in while condition. While J is less than K. Okay. So I'll add a bracket in here. Okay. There. Okay. So I would indent it. Okay. So now uh when J and K would meet, it would break the loop, then it goes out of the loop, then I is incremented, and again J and K are calculated, and this goes along. Okay. Now we don't want a duplicate triplet, right? We don't want a duplicate value of I as well. So for that, I can add a condition in here. So when the loop is started, okay. So when the loop is started, I can make a condition. So firstly, I should not be the beginning index, right? Because I don't have to check it when I is equal to 0. So I check if I is greater than 0 and nums of I equals to nums of I minus 1. That time I would break the loop. Okay. Because if the value of I is same, right? Minus 1. Okay. If it is same, so then I would skip that element because because that will give me the same answer, right? Because my J and K would also be same. So that will give me the same answer. So I have to skip that condition. So that will help me avoid the duplicate. Now that would help me avoid the duplicate for the first index. Okay. Now what about the J and K, right? So I want to avoid that condition as well. And also in that else condition, once I add the result, so I have to increment J again, right? So I'll increment it here. Okay. Now in this else condition only. I have to check like if the J, so suppose I'm here. This was my J. Now I incremented the J. Now J would come here. Okay. Now if I'll compare it again, so that will again be computed to 0. The sum of minus I plus J plus K, right? And that will give me a duplicate value. But I don't want a duplicate triplet. So I have to skip over duplicate values of nums of J as well. So for that, what I can do is until until I'm getting a duplicate value, I'll skip those. So I can take a while loop until nums of j is equal to nums of j minus 1. So if both are same, and I also have to check that j is less than k, because if we are at the equal index, then it would give us the index error. Okay. So I would increment j until then, right? So this way, the j part is skipped. Okay. And so now this code will ensure that duplicates would also not take place. Okay. And I have to return the result. So now I would return the result. So this loop is so I could return the result. Got it. So now let's run the code. Okay. So it's saying it's accepted. So base cases are running fine for us. So now let's submit the code. All right. So it's working fine. It's working as expected. All the test cases are running. So I hope you got it. I think it is a bit confusing question. But you just have to get a hold of the index, like how we are iterating. So firstly, we fix the I. Okay. So how we have fixed the I? We have started a for loop. Okay. So we are taking one value of I at a time. Okay. We are taking j as I plus 1. So j would be the next index of I. K would be the last index of the array. Okay. Now we are running the loop until j and k meet. Okay. And we are checking if the total of all those indexes is equal to 0, less than 0, or greater than 0. Based on that, we are incrementing and decrementing our values, right? And when the total is equal to 0, we are adding it to the result. And to ensure that we are not adding any duplicate values, we are checking if the old value of j is equal to I. And same for j. If the old value of I is equal to the new value of I. So if that is happening, we are already incrementing our index. And later on, we are returning the result. So I hope you got it. I think you should try it yourself. You can see the video. You can visualize it. You can write it out down on the paper. This is a very popular problem, and I think you need to solve it on pen paper first, and then you might get a gist of it. And I'll see you in the next video. Until then, bye bye.